Welcome to the second video titled Setting Up a Local Recursive Resolver. The previous video we learned setting up your system to talk to a name server. In this video we will first install bind 9 on Ubuntu, then add and allow recursion entry, and finally use the forwarders. Since all attempts to access a website require that you look up the hostname, the responsiveness of your name server can have a large impact on the loading of a web page. A slow name server can delay the initial loading of the web page, as well as the loading of the various embedded images, videos, and JavaScript, which might have been pulled from third-party sites. We'll be looking at setting up our own recursive name server, which will help cut down on the round trips between you and your resolver. We will additionally configure it to forward uncached queries to a public recursive name server in order to take advantage of their caching. Let's see how to do it. Let's set up the local recursive resolver. Install bind 9 on Ubuntu. This can be done with sudo apt-get install bind 9. On Red Hat and CentOS, it can be done with yum install bind instead. For other distributions, consult their relevant documentation. Add and allow recursion entry in the options section of the bind 9 configuration in order to prevent it from being used for denial of server attacks. Consider listening to only your internal IP address with this option. If you want to use a forwarders, add to your options section. Now let's see how it works. While your mileage may vary from distribution to distribution, bind 9 is often distributed with a default configuration that acts as a recursive name server with no restrictions on who can issue queries against it. This sort of configuration can be abused by people looking to perform a DNS-based amplified denial of service attack by sending you a spoofed UDP packet containing a request, which results in a large response. This causes you and a large number of other servers to send the large responses to the denial of service target. The allow recursion setting that we've provided tells bind 9 to only answer the recursive queries from your local network, and the special local host variable that includes all IP addresses configured on the server itself. Once this setting is in place, the server will respond to these queries with a short, refused response, rather than a potentially large data response. Listen on takes restrictions one step further by allowing you to tell the server to not bind to particular network interfaces at all. If you're running on a router with multiple interfaces, you can choose to have bind 9 to only listen on the internal interface. Depending on your firewall configuration, this means that someone sending a request on an external interface will either get an ICMP destination port unreachable message or no response at all. Finally, the forwarders setting configures a list of DNS servers that you can go to in the event that it does not already have an entry cached. In this case, we're using the two public Google servers again, but you can choose to use your ISP's name servers instead. Now I'll provide you with some extra stuff. The DNS protocol typically operates over UDP port 53. This is due to the low overhead nature of the UDP protocol, which does not require any sort of handshake to create and then tear down the connections. Over UDP, DNS is able to issue a single packet for a request and mostly receive a single packet as a response. Due to a limit on the maximum size of a UDP DNS request or response packet, the protocol can switch to TCP instead. The maximum size of a DNS request or response is 512 bytes, unless EDNSO is being used to increase the size to 4096 bytes. Any packet larger than those sizes will trigger a switch from UDP to TCP by the server sending a partial packet with the truncated bit set. While a majority of DNS traffic that you'll see will be UDP, keep in mind that during troubleshooting and firewall rule writing, you may see TCP as well. Nice! In this video, we saw how to set up a local recursive resolver. In our next video, we will configure dynamic DNS on your local network.